going to do something hopefully fun. I am working on this library that I've been making, this kind of like a cross-platform library to wrap all kinds of operating system stuff. We're going to talk in a little bit about why I'm making this and what's the purpose of doing this versus using something else. But this library is mostly a learning opportunity for me to get into all kinds of details that in the past other libraries have solved for me. Like if you use something like Juice or something like that, that solved some of the problems that I've been dealing with. But I wanted to know more about how operating systems work and how I can get into the weeds of, in this case, it's going to be mostly Mac OS, but later Windows and other operating systems, and to find out more about how it works and how I can reason about their model to do things. And this is already kind of in progress. I've made a bit of work on it. And some of the work I would use something like Claude Code because there's some operating system details that I just do not know. And it's very useful for this like little interesting feedback, even though I am going to be kind of reviewing and coding myself every single bit of it. So yeah, it's pretty interesting. It's pretty fun. We are going to we're going to do some cool stuff. Let's see if I can also start streaming from my Instagram. Is it working? Is it not working? I can only see Aznek. How are you saying your name? Azniax? Azniax, right? Am I pronouncing this correctly? So hey, how are you doing? Thank you for tuning in. And we're pretty soon about to start to do simple programming. I'm just trying to get the Instagram feed to work, which it does not for some reason. Right. The question is, listen, are you aware of crypto? Yes, I'm aware of crypto. What should I know about crypto? What am I missing? What is great about crypto that I do not know? This is a fun conversation. What if I create a coin and dedicate fees to you? Would you endorse it? No, I would not endorse it. I would not endorse it. Yeah. Let's see why. Oh, here it is. Oh, why can't I have a little background on top of these messages in my software that I'm using? Anyway, so my name is Eyal Amir. Some of you know me from music or coding or music software, and I have been dealing with that. And there's a lot of things on this channel to do with C++ programming and plugins, audio plugins, and all that. And I want to focus on doing something that is hopefully interesting. And let's see what we're going to do here. Okay, so let's see what is it I'm trying to do here. Let's see if we can explain this. So when you're doing, there's a lot of things that if you're doing them and you want to do them in a way that makes sense, you want to write something that deals with operating system primitives. And here's what I mean by that. Let's say you have a UI app, right? Your app shows a window. That window is not something that plain old C++ can just call. The window is something that Mac does differently, iOS does differently, Linux, Windows, they do differently, and you have to interact with that somehow. And there's actually quite a lot that we need the operating system to do. So just to do something basic, like let's say you want to send a network request, like an HTTP request. This is something that usually you need some help from the operating system with, or you need help from external libraries that are eventually trying to wrap that and create some of that concepts in line. For example, if you want to make an HTTPS request, you might need to bring in OpenSSL because that is a requirement for doing something like this, or an equivalent library. So you run often into the need to interact with something that is cross-platform and can kind of abstract these operating system deals from you. And those exist. Like if you use Qt or Juice or other similar libraries, they offer those. But those libraries sometimes have limitations. Some of them are just limitations of cost and pricing, and some of them are limitations of the way they decided to use the API. And we're going to get into that with stuff like graphics. So there are situations where some of these cross-platform libraries have made a decision to create a model that works for certain things, but then it doesn't really scale well for a lot of different applications. So what I was trying to do is I was trying to kind of dive directly into this and see if I can get this to work. I'm still very confused about why. Salesforce does not want to stream to Instagram today, so no Instagram, doesn't matter. Anyway, thank you for joining. Feel free to write questions about what I'm doing in the chat section. I will put it on screen so we can discuss it. Yeah, so I've done some work here. This is not me starting from the beginning. So here's where I am right now. I have a few different layers of abstractions. One of them has to do with what we call the event loop. So that already kind of exists. But just to explain, macOS, for example, likes you to do things in an event loop in an async way. Okay. So macOS tries to do things in an async way. What does that mean? That means that they don't really, like, for example, in a lot of games, I just have this main. Let's remove my face here for a second so we can see a bit more of the code. Okay, here I am. And like one thing you'll see in a lot of very basics to game engines is that you'll have like something like you'll have a main function, your C++ code, then you'll have something like a while loop, like bool should game run equals true, and then we kind of like while should game run, and then you're gonna handle events, handle keyboard events, draw, calculate physics, like you do all this stuff in this game loop, but modern operating systems don't love this model. This is something that you can still do if you're making a game. There are ways to make this happen, but at least on a PC and a Mac, you can do that. But it's not ideal because what happens is the operating system actually would like to push things in the middle of this. The operating system wants you to be able to respond to events coming from the system, like notifications about the window. And this kind of a model that you see a lot of games is now not very viable. I mean, you can still do this in some kind of games, but for apps, for example, it's not so good. Like what you usually want, you want something that's like continuous and keeps working and has these like different windows that operate asynchronously. Nothing is going to block the thread. So one of the things that I've already done here is that I've made a couple of abstractions to create a message loop. What it means is that the simplest way to do this is I have this library is called the ACP, and you can select the ACP apps calling this thing. Let's see. Sorry, threads. ECP threads run event loop, right? The idea is that I can create a function that says ECP threads run event loop. And this is taking a function, right? The function could be something like, let's ignore this code. The function could be something like, my function, right? And the function could have something like cp log hello, and we can pass this function here, and then I can run it. Oh, right. This is the GUI app. I need to run the console app, and this calls hello. And then we can, this is interesting because we can actually continue running async operations when this happens, right? If we just run one function, it's not very interesting, but it gets interesting when we want to do something like use a timer, right? So this is where, and we want to continuously be called with something. So to do that, I've made a slightly more advanced model where instead of having just a function is kind of boring, then I did something that creates a structure that you create called an app. It waits for the message loop to run. It creates your object, and then you can keep running things until you finish. So here's an example of what this could do. There's an app here. And this track is good because this already gets created when the message thread is running. So the loop is already async and running. And I can call it timer. And this timer is going to call my update function. Let's not do it 60 times a second. Let's do it 1 time per second. So it hertz. And let's do, let's do something like log, EACP log, timer called something. Let's try to run this. And every second, I'm going to see, I wrote timer, but this is what it does. It's called a timer every second. And this is good because this lets us create some continuous in our app while still letting the system do its thing, which we would need very shortly. Because now the system can call different things. It can process windows, let me know about events from the UI. If there's a network request, it can call me back after the network request has been finished. So I can use this message loop to process logical things in my app, and I don't need to block anything. I don't need to while loop and wait myself on something. I also don't need to thread sync anything here because if my app is structured so that this message thread is the main thread where I'm doing application-related things, like I don't know, maybe I'm calculating how many bars are going to be in my song before I play it or something, I now don't have to lock. I can have events happen, and as long as they're happening in this thread, I'm good. It's all a logical thread. This is very similar to how JavaScript or something works, because those languages gives you a model of single-threaded processing. I'm just going to have some music that I'm playing in my background that hopefully you're not hearing, because that would make my stream leave. So hopefully you're not hearing it, but I'm hearing it, and it's really cool that I can listen to music and not send it to you. Okay, so this is useful, right? This is useful, and we can even do something. Let's try to do something more fun with this model. For example, we can say, hey, let's make this thing gets called. Let's instead of doing this, let's count how many times we're running something, like num times equals 0, and then I'm going to do something like a log string sometimes. So we're going to define a way to string. We need a way to fix this. This will be fixed in a second in the little logging library that's associated with this, so that you don't have to do std to string. So let's do std to string num times plus it's fine, num times, and then let's increase num times. And if num times is equal to 10, then let's just quit the app. Right, so let's do that. Let's run it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, look at this. Ooh, I might have a bug with quit. Ha ha ha. There might be a bug in quit. Let's fix the bug. You see, that's what happens when you just try things. So quit is currently broken. And we need to fix this. So instead of doing apps quit, I think I need something else here. So it's possible that my low-level implementation, and I guess this is why we're doing this little stream here. So it looks like I'm stopping the event loop. I'm first destroying the app, right? So this should look good. This is destroying the app. And then I'm stopping the event loop. Let's see, how am I stopping the event loop? Okay, so this is a good chance to see if Claude knows something about this detail. So let's bring Claude in. And let's see what it's going to do here. So this is in ACP core app. In core app, app.cp, have a function called quit. It seems like calling it from within the event loop isn't always quitting the application. You can check the console app example in apps console and build it to verify. Before I do it, I'm just going to call quit here because I don't want it to look at a timer, or make it just one. Let's see what it does. It's very interesting to vibe code with Claude because a lot of these operating system deals are actually very, very abstract. Like I usually after it does something, I'm going to need to read for a little bit using documentation. But documentation of these operating system details is not always as clean. So when it shows me a usage, I can actually focus on which APIs I should search, which isn't always obvious. Does it want me to run? Let's try to do run console app timeout. Yes, okay, right. How's everybody doing? How are you doing today? When stop null, this is a flag indicating the app should stop. Event loop doesn't actually exit until it processes another event and checks the flag. Wakes it up and doesn't generate an NS event. To fix, post a dummy NS type application define event. Okay, let's see what it did. So let's see what it changed. So when it posted a dummy event to ensure that the process has a stop request. Okay, so there's something that I don't like. I don't like the way this is written. So let's kind of rewrite this a little bit in a way that is a bit more clear. With, and instead of that comment that it was leaving, let's have a look again. Where is my this objective C++ part? So let's give it some other name. Hello, talk to text AI. Are you an AI or are you a person talking through AI with your AI program? What are you? Event type, locations, and spike point. Okay. So what I'm going to do, first of all, let's see that this kind of works. Now it runs and stops. Let's now try to make my demo app a little bit more explicit. So, a little more interesting. So let's post a few times. Should be 1, 0, 1, 2, 3, 4, and quit. That's good. Okay. Okay. So talk to text AI is a real person. Here you go. Here you go. You can never know nowadays. You can never know. Am I a real person? Who am I here? Who are we here? Okay, so already this is better. Let me commit this and let's say event loop. Add a dummy event for making sure that the quit message is run. So what I'm doing here is I am creating a cross-platform abstraction library around things that the operating systems like Mac OS, Windows, etc., are allowing for you, and it's a way to create a very low dependency. Right now, it's zero dependency way to do things with the with your with apps that you're writing in hopefully a way that would be easier and cleaner to use than using one of the more heavyweight frameworks that exists. So a big thing that we're probably going to talk about is UI. So this little app is just touching the event loop, but the more advanced stuff we're doing has to do with UI. So for example, you can draw things, write text, and animated things. And I've actually researched this, so this should be not just this particular app, but the drawing should be very, very efficient for most UI apps, maybe even games, because like other frameworks, this is using an interesting approach that should be very, very fast, at least on Mac OS and iOS, and hopefully also on Windows when I get done with this implementation. But yeah, the idea is that this is something that should be very, very simple to use in terms of the API. Like for example, here's this app that runs a timer. It's a couple of lines of code or one line of code to spawn, the event loop. And then, if you want to do something, you can just write like a stack object to the timer. You get a timer. With the UI, interface is still not as clean, but it should be relatively straightforward. For example, this is what you have to do to spawn a window. You just say, hey, here's my window in the app. Here's a view. Your views can just stack together these like subviews. And we're going to talk in a little bit how do you create this approach to actually paint things and draw things. This is all in progress right now, so not a lot of it is perfect, but it can do quite a lot of useful things already. So talk to text AI says, nice, I'm using Tari and Electron.js. What's Tari? Is Tari a JS framework? I'm looking it up. Tari. Right? Small good cross-platform applications. Yeah. So what are you talking about? Okay. So but I think that we're talking about something that runs a web browser, right? if I understand correctly. Yeah, it's a web view, and I'm gonna I'm actually, one of the features we'll do. I might do it even today, is add a web view to this cross-platform thing. So this should be a good solution for some things. Just put in a web view. Perhaps it'll be fun. Maybe we should start even by implementing this, just to see how that works. It should be relatively straightforward on macOS. I'm trying to go with something that would hopefully be more native. So this is more for native applications, but using WebView is definitely a legit solution. I've created a couple of apps recently that we're using WebView. They've been doing pretty well. I think it's so this is simple as opening a window in Windows and macOS and Linux. In Windows, this should be a lot of bloat, for example. Right. So yeah. So I'm not streaming from a Windows computer right now, but probably one of the next streams will be me kind of abstracting this little bloat on the Windows side. I wonder, why can't I see a background? Why can't I see a background on this image? I can show this on this like clear background, which means that it's hard to read, at least for me. But yeah, there's definitely some bloat. Like even the Mac stuff here, there's a lot of bloat. You don't see the background here because I've abstracted all of this. Like the idea is that if you have a C++ application, you only include a C++ header, but I'm abstract. So for example, if you look at the windowing stuff that I'm doing, there's a bunch of stuff going on over there. Specifically, for example, we're going to get into that pretty heavily, but the windowing stuff. There's a lot of like objective C++ code with the types of windows and the options. How to set up the window. It is pretty big. Like it's not very simple to just get a window showing because you have to click the window, then you have to attach a view. The view is a whole separate thing. There's a bunch of code here that deals with the views, what you call NSView, and then later I'm adding this thing called layers, which has to do. So I'm adding all these things, but the idea is that the user should hopefully be spared from this work, so that when you're making a GUI app, you can just say, oh, well, here's a window, well, here's a view, and then you can create views that, like, for example, here's a view that, let's look at this fill direct view, right? So this is just a view that draws a path. And when it gets resized, it regenerates the path, right? So, but there's a lot involved in the underlying kind of element of this, which we would probably talk about quite a lot. Stopping by to say hi. Hello, Sandro. Am I saying this correctly? Sandra? I can't say people's names. I can't even speak English, but I can definitely not say people's names correctly. I'm sorry that I'm botching it. Everyone are botching my name too. So I feel like I'm doing that for everybody now. Okay, so let's see what we're going to do. Let's see, what are we going to start with? So something that I was dealing with previously had to do with text. My text handling is not so good right now, even though it kind of exists. It's not great. I also wanted to improve the API. The API is kind of wordy for a lot of simple things, so I wanted to simplify that. Let's see, what should we do first here after drinking some water. Yeah, so this is going to be quite substantial, I guess. Starting from a simple window to drawing simple shapes, complex shapes, vector graphics, Skia, also font rendering. Yeah, so we actually have some of that. I already have decent support for vector graphics right now. Like for example, everything you see now in these shapes, I kind of drew, simple, but you can draw any path. Like there's a path abstraction here, and you can draw more complicated path, which we're going to start. Maybe I'll do like an SVG even importer at some point. But yes, it is a pretty legit drawing API even now. Like there's now it wraps two separate APIs actually that you can separately use. One of them is what Apple calls core graphics. I think in Windows would be called Direct2D or something like that. That is more of like a CPU stroke pipeline. So I can, for example, go and if I wanted to use that, I can inherit from view. So here I have a view. Let's start by creating another app just so that we can simplify a lot of these things from the example. So let's call this. Let's make a new app. Let's call this simple view. I'll do this for testing. And I'm just going to copy the CMake file. Simple view. Let's call this simple view. This is the entire setup in CMake for the build system. Just link with the ACP graphics and set up like macOS bundle information about your app. It's good. Let's make sure that I'm using the right target here. And I can just remove all this example stuff, and we can start from the beginning. Okay, so this is basically the minimal version of an app that shows a window and has some drawing inside of the window. So resizable window, we can also make it not resizable. Like for example, when we create the window takes this thing called window options. So I've currently didn't pass the options, but I can do something like window options, get options. Get window options or something, and I'm going to start with the default window options, but I can do something like options dot flags dot. I think that there's a default flag. The default flags is resizable, but I can use like clear flags dot place back window flags. So it's like borderless. Let's see what the default flags are. I just completely forgot. So these are default flags: titled, closable, which is resizable. Let's bring in some other flags. So I can do something like auto flags equals options.flags. So flags clear, and I said my own flags. So I'm not going to make it resizable, for example. Where was I? Return options, and then let's initialize this window with my different window options. Let's see what happens now. Now I have a window and I cannot resize it. You see it's blocked from doing that. And what other things were there? Like, is it closable, right? Or let's remove titled, for example. So it's not titled. So now there's no title, right? It's a cleaner window. So you can, it's all been abstracted so that you can just customize whatever it is that you need. And what are the things that we'll talk about soon is how do you interact with this window? Because sometimes what you'll do in a real life situation is you might even not use my library to draw. You might use this library and then use IMGUI, or then you'll use Visage. It's a really good drawing library, or you'll use something else. So we'll talk about the handoff as well, where you can use this to customize your window and event loop, whatever, and then call something else. It would be probably a good use case for a library like this. So, but yeah, the idea is that everything should be relatively composable and in a way where you can, you can make your own app with this and not like feel like this burden. But by the way, another big thing is because this is only using like operating system things, and this thing compiles extremely fast. So just to give you an idea, let's open my massive thing, and I'm just going to rebuild the world, right? Let's rebuild my whole thing, and you'll see that let's even rebuild all. Let's rebuild even all the examples. Rebuild everything. Rebuilding everything is going to take less than 2 seconds or something, right? For the whole thing, including all the examples. Maybe after I add some code, it's going to be 4 seconds. But it's never going to be something that is a burden on your project. It should be very, very easy to compile. Should be easy to link with different ways your app is set up. And so it's meant to be something kind of lightweight, not as heavy and frameworky as like somebody mentioned Skia. Try to build Skia in your app. Skia is massive. Takes a long time to app. It requires a very specific build process. It's a huge dependency. It's not going to be integrated easily into something like a plugin. It's not going to be integrated in an app that you have that is using like SDL or whatever. It's going to be a big thing. It's going to make your app kind of bound to this. This is meant to be more of a modular, clean thing that you bring in for certain things. Like for example, the networking thing that we'll talk about. There's a little bit of networking abstraction already for simple HTTP and HTTPS requests. These are things that usually you would have to bring like OpenSSL in, but I wanted you to not need to do that, to just call a function and make it work. And don't if you're just prototyping something, I don't want you to be attaching yourself to my framework necessarily just for this call. And I see MobiPixel. Hey, everybody's working for the weekend. MobiPixel is an amazing YouTuber, musician. YouTuber, he was a musician, also a developer, I believe. So it's great to have you here. Yeah, so this is like the idea of this like basic framework I'm creating. Let's keep this thing more interesting. So let's remove this window options. Let's just stick with the default window. And that is that you can still question is, what SVG lib would you recommend then? I mean, that's a good question. I think people using Nano SVG. I haven't looked so deeply into this. I actually need to find a way to do SVG in this library at some point. So I'm still not sure. But yeah, Juice has an SVG player. I'm using that in plugins. It's great. It has some things that it's missing, but it's usually pretty good. We'll see. Like even during this stream, I'm probably going to start implementing WebView. So WebView embedded in your app could be a way to go for some SVGs. Depends on what your program is doing. I don't know. We'll discover it all together. I'm not sure exactly what the solution is. So we're going to discover a lot of details of what would be best. Because the main thing for me is also to make sure that, at least from my library, I'm not necessarily trying to do the world here. Like some things will probably be better off by using a library. Like, hey, go and use Nano SVG and make that work, or go use a more heavyweight metal rendering library, or shader rendering library. Like so, but I would want to at least make sure that I'm providing hooks for these libraries, so that you want to use something that does high-end, shader rendering. At least I give you a way to get the window hook and stuff that you would need to make things appear on screen. Okay. So, with water. Okay, so one of the things that I said was there are multiple ways to draw with this library conceptually. Not all of them are fully baked, but this is the idea. So one way is I can take this thing called a parent view, and I can draw into it. That would be similar to what Juice does, by the way. So I can go and override a virtual function called paint. If you've ever used Juice, you are familiar with this concept. And this lets you do stuff like, it gives you like a context to draw on, and I can just set that context, set color. Let's add a color. Look how, I don't have presets for all the colors here, but let's make it white. This is white in color land. Just so this is the color. Got this extra dot and this dot. So does it work right? Oh, comma. Okay, so I'm setting the color, and then I can do something like context dot fill ellipse. Do I have an ellipse here? I thought I had an ellipse. Maybe I removed the ellipse function. What's missing? Oh, probably I have to do it with a path. Okay, so let's say that there's a path. Let's have a auto path equals path dot add ellipse. The ellipse would be get local bounds, and then I will be context, and it will be fill path with this thing. Right, so that is more of a linear way to think. That's if you've used Juice, it's very similar. Let's run this. Okay, and I have this stretchable ellipse that stretches to the size of the window. And this is great, but the thing that you would find pretty quickly, and you would find that in Juice too, by the way, this is actually not very efficient. This way, if you were working like this, that means that the operating system has to call you all the time whenever something changes, above or beyond that thing. They always would have to call you to recalculate this circle. If you start to stack a bunch of things in this UI, you will see that you're going to get this paint call is going to get called by the OS, right? Whenever something changes, and if you'll have buttons on top of the circle or a bunch of things, you'll see that this gets called quite often. Like for example, here I'm just debugging this. I'm going to move something. It's going to get called. It's going to redo this whole path. And you can improve this a little bit. For example, I can cache the path, right? I can say, well, instead of having the path be created all the time, I'm going to cache the path right here. And I'm just going to path clear, right? So that's a little bit more efficient. And this is the kind of thing you would do in Juice to reserve some memory allocation. That makes it a little bit better, but it's still not very fast. It's just not a fast way to do things. Instead, I started by working with this model, and this uses what Apple calls core graphics, but I am slowly moving away from that model for performance reasons. Instead, what I'm doing is I'm using this idea of descriptive layers. That is something that Apple uses with their framework called Core Animation. The idea is, instead of having like a raw paint call, the raw paint call is very low level because the OS doesn't know anything about what you're drawing there. It just calls you and you're filling it up with drawing instructions. And then later something changes, calls you again, you fill it up with drawing instructions. There's no way to have any kind of smart caching. The only caching you can do in this case is you can cache the entire drawing of the thing into an image. But an image is very, very heavy. Like an image takes a lot of memory. The image is not using a lot of the layers that GPUs can provide. So this is just not very doesn't scale very well. And you see that in in Juice. If you use Juice, then you start to draw a bunch of things. Sometimes you have to cache things to an image. It's okay, it's okay, but it's not the fastest way when you think of an app that could have like many thousands of these drawing instructions, tens of thousands even. So what the path I've been starting to take is, instead of doing this paint call thing, what I'm doing is I have this thing called a layer. For this case, this is going to be a shape layer. There are different kinds of layers. And let's call this layer. And what this does instead is, instead of having a paint call, I'm going to remove the paint call. I'm not even going to use it. And instead, I'm going to do two things. In the constructor, I'm going to connect this layer. So it's going to be add layer. That's how I'm going to let the this view knows that it's kind of associated with this layer. And then the only thing I'm going to do is whenever a new size happens, so a size, whenever a recess happens, now I'm going to create the path. So I'm going to do something like path equals path, and then I'm going to do path at ellipse, we get local bounds, and then layer set path. And if you also now want to fill this in some way, the fill is always going to be the same. So the fill is going to be like here, for example, it's going to be something like path layer dot fill color, and let's make this like this is going to be white. So this is similar in terms of what it's going to draw. Let's see what this is going to look like. Here it is. However, if I am if I'm going to have animating things, which I will show in a second, and a lot of different things moving on top of this circle, right, that would invalidate the drawing area, this would take 0 time to draw, because the operating system now knows everything about this layer. It knows that it didn't change unless I resize the whole window. So it's always going to know that it's the same. And it knows what's changed also. So it can cache, like if we have gradients, all kinds of stuff we're going to add. The operating system can just cache all these different elements. It knows all about them. It knows when only one of the elements has changed. It keeps like a little diff in the tree. So this is dramatically more efficient. And you'll see in when we're starting to create an app that has thousands of elements, then you'll see that CPU usage goes to almost 0. Maybe it's like 1% for like the entire app for things that are mostly static, because the static things are going to be very efficiently cached inside of layers. And this is the one thing that these draw calls are just not able to do unless you do all kinds of hacks around them, like pre-draw to an image and then do this. So so this is very, very useful. It's way more friendly to the GPU. And you can do this if you're writing your own, shaders. Shaders can do everything that this does, but with the shaders, you're going to have to manually do all these things like anti-aliasing text and whatever, which is very complicated to do correctly. And here we're getting this. If you've ever drawn a circle with OpenGL, it's not so easy to draw a good-looking circle. Like there's all these ways to do anti-aliasing. You have to do these trade-offs. But here we're using the operating system. The operating system does know of efficient ways to do these things. It has especially in macOS, there's a great way to stroke text. I think it looks beautiful. A lot of FreeType and all these other libraries are not looking as good as the macOS one. So it's just so much better to have these performance events just while getting a native, beautiful look that the OS is giving you. And the question is, so it is like a paint function in SDL while loop called the whole time. Yes, right. That is a good reference. Like SDL basically tells By the way, this library, when you think of like conceptually, is similar to SDL. But in SDL, if you're using the raw render, right? Because SDL now has a GPU renderer, which is very, very efficient, but is way lower level, right? So if you use the SDL renderer, you're going to have to call these paint commands all the time. Those are, you can get faster with them, but they're not super fast. So you'll run into the performance limitations of an SDL renderer, and you can use what SDL3 calls SDL GPU, but SDL GPU is way more lower level. Like you're going to have to start to write your own shaders and implement things, and if you want to do text draw, you're going to have to anti-alias the things. So it's going to. You could definitely get an amazing performance from using SDL GPU, but you will be operating at a way different level of abstraction, right? And if you're making a game that has custom 3D rendering, you have to do that anyway. But with apps, you might not want to start figuring out how to efficiently pass buffers and write geometry shaders. And with most apps, you might want to be more, even with simple 2D games, you might want to do something more on this level, like drawing things, animating them. And and like we're seeing in my different other GUI app, we probably should now make this, do like a performance benchmark thing for this. But the idea is that here I have, you see there's text here. I think the font, it looks super nice. I have three widgets here, and I have something that's animating. But even though I have all these things moving, and I'm going to do a benchmark soon with thousands, which I did when I was writing this. But what you will see is even in debug builds, this goes down to like 1.5% CPU, almost nothing. With release builds, it might even go below that. And even if you have a lot, even though it's animating, there's no paint function that's called here. I have a timer here that's moving the circle, right? It's moving here. It's moving it at 60 frames per second, which you might see kind of jumpy, but it does look very smooth on my machine. But even though this is animating and changing both the position and the opacity, it doesn't actually call the paint function. The OS knows that it's the same shape. It knows that I'm only changing the opacity as the animation happening. So it can cache, drawing of a circle. It can cache the color. It can cache all these different things and can just change what's being changed. And it's very, very fast. So even if I have things behind it, on top of it, we're gonna work on all these soon. At least theoretically, this should be way, way more efficient than SDL render, right? It should be way more efficient than Juice rendering for most things. Most things that aren't low-level GPU ready. Okay, so I do want to continue and see what we're doing here. I don't want to draw these parent view stuff now. Let's keep an empty parent here. Oh, that's nice. I was looking for an FPS log somewhere. Yeah, I'm going to do this. This is. I mean, I'm getting the example here is not great for benchmarking. It's just an example that I've been modifying to show features of the library. But when I was working on it, I did do some testing, and yeah, with this, I'm getting the maximum FPS for the monitor, right? Which is, I think this particular monitor, I think it's 60, but with my laptop, I think it's 120. Like you're getting the maximum, but it doesn't mean anything because it's just like three rectangles and a circle, right, and a bit of text. But you'll see that if you'll do the exact same thing with Juice, you'll still get the same FPS because it's not a heavy burden on the computer, but you will see a way more CPU usage. Like you'll see the CPU goes to like 15% or something, or 20%, because continuously stroking these paths is heavy. And if you're able to cache them, then your CPU doesn't need to do much. So it's not really about FPS at this moment. It's just about reducing CPU load for now. But it would be about FPS, which it should be the result of that at some point. Yeah. All right. Okay, let me just commit this simple edit, simple view app, just because I'm going to use this example often. All right, so what should we do next? There's a few things that I have in my task list for now. One of them might be a good start. Something I haven't done before, so it's going to be interesting, is I want to add an option so that each of the views can be a web view. Let's start with a web view. Now, I don't know what it takes to do a web view, so let's ask Claude to get me started on a web view, see what that would resolve to. Right, so let's do something like, okay, now want to add a web view which is a part which inherits from view, but spawns a native web view within that view. can you help me implement this with a native macOS backend? Let's see what this does. Let's see what this is. Let's see what it can figure out about this. Because I don't remember the exact API. But while I'm doing this, I am going to look at what the exact API is, which I don't remember. So it's going to be like Apple WebView, WebView Docs, WK WebView. So this is probably the class that we need. Auto display is interactive, and it is an NS view. So my view class is translating to an NS view under the hood if you're on Mac. Sorry, this is Objective-C, but this is not Objective-C. I think this is Swift. Hopefully, there's also Objective-C code in the examples. Oopsie. Okay, so let's see what Claude came up with. Want to proceed? What does it want to do? I'm going to look for NSVs here. There, sure. Here's that. Go and search my files. I tried WebView in JavaFX. Broken, then Qt broken. Really, it's broken in Qt? But in macOS Swift. Wow, it's broken in Qt. I'm really surprised. Qt is very durable. Usually Qt is one of the best maintained libraries. I'm really surprised that there's problems. I've used the one that they use in Juice, which is a wrapper probably around similar things I'm doing right now. And we have a couple of apps that I've worked on with this. One of them is Fuel by Music Hack. Maybe I could show this a little bit while Claude is doing its thing. Do I have it installed? I have Fuel installed on this computer. This is a new computer, by the way, so I'm not sure what I have and what I don't have. So let's double check. No, I don't have it installed, so let's install it. So let's go to Music Hack, Fuel. So it's this plugin. I'm going to log into my account. Get the email. Where's my email? Here it is. So let's get Fuel installed here. Good. So basically Fuel, let's load it in Plugin Buddy, which if you are not using, you should be. This is a free plugin host. Let's you run instrument along with an effects chain, which is free by Modalix. Anyway, in Plugin Buddy, I am going to go here, rescan, and then I should have Music Hack Fuel. Okay, so this is Fuel, and this is using a web view embedded in a C++ view, right? And it works very well. There are advantages and disadvantages to using web view, but it does work. This is a full-on web view using Feet and using some JS libraries, and and not only that, you can see it, this window is a C++ window, but the plugin in here is using a web view, right? So this also works well where you're embedding one window in the other. And this is using the Juice web view, by the way. So so at least in theory, this should work. We have this running on Mac and Windows. This plugin is pretty successful and works pretty well. Okay, so let's see what Claude has done for me. Although for now, you want the web view. Basic display only, loads URL web content, no navigation controls, no navigation, no URLs back for reload, plus full interactive, navigation plus JavaScript evaluation. I definitely want the full interactive one. Let's do the full interactive and see what this does. I have no idea how much work it takes to do, but let's see if Claude can at least give me pointers on how they use the APIs, and then we're going to refactor what it does to fit how I think about this problem. By the way, if anybody's coming to NAM, I will be at NAM. You should come and hang out. Or you could play. You could hear the music. I'm hearing. It's so good. I'm gonna have some Claude to do a job that's way too complicated. We'll see. Seems to be touching a ton of files. What's so annoying is that sometimes these agents, these LLMs, they create so much code that you just don't have to, like 90% of the time, I just have to look at what they do, just remove things that are completely unneeded. By the way, you'll see a lot of objective C++ being written here. I was trying at first, I did a few experiments of making Swift be used for the Mac native backend, but I actually ran into a lot of problems with that. One of them is that the build system, especially if you're using CMake, is kind of off. Like sometimes you need to do a lot of things to match the Swift build to regular build, or it's kind of weird. But also, Swift has all kinds of trouble moving types back and forth. There are some things that it can do, but it's not perfect. And with Objective-C, you can just Objective-C++, you can actually just pass in your C++ type and your C++ functions, and everything is way more kind of naturally builds together harmoniously. So I decided to go with that. hopefully in the future, I can just get rid of the Objective-C++ and just have Swift be there. Swift is a much nicer language to work in than Objective-C++. Claude is quite good at this. I tried Gemini, ChatGPT, and even Copilot. Copilot is great, but more on the motivational side. That is a very good description of LLMs. They're good on the motivational side. Oh, Claude is definitely having his way with my project. I have no idea what it's going to do. It builds things, get errors. I'm scared by what I'm going to see when I'm reviewing this. Okay, so it did something. Here we go. Okay, it says that it give me a web view, and I can just add this. Okay, let's see. Did it change my example? No. So let's see what it did before we're going to review. Let's see if we can just use this. So, how do they call it? Web view. Web view. Okay, so Objective-C++. I only know Objective-C. How does it work with Xcode? It works beautifully with Xcode. In fact, a lot of the cross-platform libraries that you already know, like Juice, for example, are using Objective-C++. It's the way to do things. You might have not looked at it, but you would know if the difference is, first of all, if you'll see that there's a file somewhere called something .mm instead of .m, which is the extension for Objective-C. So .mm is basically it's like a hybrid language. So if I'm going to go into one of these MM files, you'll see. Let's see an interesting one. Like let's go to view.mm. So you'll see that I can write like actual Objective-C. Like I can go and, for example, this is like a class that inherits from, or an interface that inherits from another Objective-C class or another Objective-C interface, right? This is classic Objective-C. But in the same file, or even from the same function, like I can override a function in Objective-C and I can call a C++ function. Just plainly do that. So it's always like a hybrid. It lets you do both of these things. It's very cool. It works beautifully with Xcode. It works beautifully with every Mac thing. You don't want, ideally, like, I mean, the way I've been structuring this project, you don't want like user code to do that. Like you don't want a user to start typing Objective-C, because Objective-C creates build problems. For example, it's not going to compile on Windows and it's whatever. So you kind of have to hide it so that it only runs on the Mac path and only runs in a, kind of like hidden. You don't want like users to include a header and bring in all these Objective-C symbols from the concept of C++. But it does work, and it does let you, have this include. So I can have, I have this MM file. It can include view.h, which is pure C++ file. There's no Objective-C. But then within it, I can also include, coco.h, right, which is a Mac header or something. So there's a way to eventually kind of contain them. With Swift, you have to do more complicated things. You have to find a way to make sure that the types are compatible. They're not always compatible because you can't bring in any kind of headers. And also the build system has to be set up in a certain way. You can't just build it like an Objective-C++ file. From the context of a build system, I can go here and say, hey, let's add, it's just a source, right? this is a source here. And the compiler knows if you have Objective-C++ enabled, which I should have somewhere here, like it's like here it is, languages CXX, Objective CXX. And once I have it in my project, the compiler just knows. It knows .mm files do this, .m files do something else, .cpp files do something else. So it's very convenient. The language is still pretty rough to use, but the setup is convenient. Okay, so let's see what Claude did before we're going to review it. We are going to the simple view. It has a web view here. Let's web view. I think I have to do like scale to fit. Web view. Let's do that. Oh, It's factor. Should probably make a version that only takes one. But anyway, this works. And then add subview web view. And let's do something with the web view as well. Let's do some web view. What are other options I have on the web view? Load URL. Load URL looks pretty good. Let's go to load URL. Let's go to Google and let's see what this does. Oh, not Google. I need simple view. To the target. And here's Google, right? Here's my web view. My web view works, right? I did not check anything about what Claude just did, but it does work. And we'll see what's happening in a second. But or you know what? Let's try to do that. Let's have. I want to see what happens if I have another view on top. That's going to be interesting. Like, can I use this as a background layer, for example? Let's say that I have. Let's keep this web view, but let's also have a shape layer view called, or let's do it. Yeah, shape layer view would be good. Let's call this shape or something. Add children. I want web view and the shape. And with the shape, let's also do so that on resize it doesn't like shape. Let's do equals path p at ellipse. Like a red color with some opacity, some alpha, and then let's shape. And then let's do, let's not make it take the whole screen. Let's do something like, 10. Let's do 50, 100. Let's do 300, 200. Okay, set the path, and I also want to shape. Let's do scale to fit. I think this is correct. Let's see what I'm doing here. There you go. Good. Okay. Okay, so this is right. Now I have a native thing drawn. Notice also with opacity, so you can see that it can draw the web view below the thing. And let's change this a little bit. Let's not do this. Let's do it a bit differently. Let's make another layer. I need to improve this interface so it's much easier to draw shapes. But let's start with, I just want to call this like circle, because I also want to do some event handling here. So let's make a circle view. This would have my shape. Add layer. Resized would just do create the path with get local bounds. Where's my color? colors. Now it's going to be pretty much the same. Shape. I'm glad you enjoyed this. We're going to look in a second about the implementations. I just wanted to see that it generally works before I dive down into what Claude did here. Shape dot set. Who's going to go? Set path. Set path B. I think I might need to also do shape set bounds. Might not need to do that, but I have to think about that. I think it might need to be something like that also. Okay. That's good. Now, this is going to be the circle. So it's going to be a shape. Now, I'm just going to scale to fit the web view. So the web view is going to take the entire screen, but shape, we're going to set it here to do I think it's called shape set bounds relative. Let's make it now be 10%, 10%, but no, 20%, 20%. Okay. The reason why I did it like this, oh, I did forget. That should be shape. That's good. Oh, no, not 20. 0.2. 0.2. Okay, good. So here's why I want to test this. There's also something here about mouse events. So now I want to see that if I can go here, I can type on Google. This is the URL that I'm loading on my native web view. But if I click here, this should not. Can I make this bigger? This should block things that are below here. At least I think it does. Maybe did I make it ignore them by default? Let's put it somewhere else. Let's put it 0, 0, so it's right in the corner. No, so it doesn't block it. I still can click on Google, but I wanted to stop this. I need to make sure that the circle does something like get properties dot handle mouse events equals true. Now it still takes it. So it's not perfect. It's not perfect. It still does looks like the web view underneath is handling it. So for some reason, it doesn't go through my mouse handling thing. I need to see why that happens, but this was the initial idea. So that is that I can layer two things. So now let's have a look at how this web view is structured. This should be stupid comments. Okay. I don't know if I love this whole structure, but we're going to get deeper into this. Let's see what this does. So it created the web view. This all looks pretty much fine. Like it looks like this calls the implementation to do basic things. It's okay. All the JavaScript stuff, that stuff I probably need to look at. This does not look so good. But it's not bad. It's not bad. It generally does the things that I think it should be doing. I probably need to refactor this. It's using this Objective-C pointer that I've created, which is good. I can figure that out. That needs to do that. And there's absolutely no reason to have to separate this interface and implementation here. Just a style thing. If I'm already having this entire class in the MM, let's just have this in place. We're in line, update frame. destructor. And constructor. Okay. Okay, so it creates a delegate. Hated this. Safe string. That's funny. Create this helper function. Okay, include a bunch of stuff that it's not using. Creates all the allocate stuff, remove all these, whatever. Pretty sure I've already written this helper to do the kind of string stuff. Where is that? Core objective C strings. Yeah, I have it already. Strings to NS string. What's this message handler? Is this something that's, what is this object? Is it just a map, an order map of names and functions? Okay, structure binding, that's actually a good idea. Okay. Looks like Claude generally, I mean, I didn't dive down deep into everything they did, but generally did a good job here. Coalescing owner. Not sure why it needs to check owner. Can owner be null PTR here? It doesn't make any sense. I think it can even, it's like an extra check that's just not needed. How can owner be null PTR here? Maybe just when it's destroyed or something. It looks like some overly cautious checking, I think. Right, when is owner going to be null or nil? Yeah, I think it's possible. All these like, I hate when it does this, like checks for a bunch of things that just make no sense. I don't need to check the owner here. I'm checking C++, such a stupid language. This cannot fail, in my opinion, because the lifetime of this thing is connected directly to the thing that owns it. So there's no way for this to be null. this, okay. I absolutely hate this JavaScript handling function. Would never write like this. Come on, functions with names. I hate when it just throws a bunch of code at you and just like, hey, this works. Try this. Anyway, this is okay for now. Might be able to even commit this. Let's even remove this circle stuff. Let's just see if I can. So my raw web view again. Yep. Let's load some other site. Let's go to, I need to be able to load something locally. So I need to figure out a way to do that. Basically, I also, but do I have, can I get some local site here? Okay, first of all, let's send it to www.ayalamir.org. It's my website. Let's go there. Look at this beautiful website. Seems to be handling things pretty well. Let's go to my music page. That's good. And I think if I'm going to work on this, I need to figure out a way to pass a local HTML so that it's stored in the binaries. We might need to have at least a few options about that. Yeah, but this would be a good start, to do web-based. Let's see how much memory this takes. Probably not going to be the most memory efficient, but it might be running out of process. That's also, I might not even know. Let's see if is the Mac thing going to tell me. That's funny. Here it took like 100 megabytes on a different process, basically. And it opens a bunch of other processes, right? It can open a process for graphics and media, a process for networking. It opens a bunch of these. Probably other processes that I'm not familiar with, like have to do with Google. Probably not Chrome. But... Okay, this is a good start. I'm going to commit this. Added initial implementation of WebView. All right, and I think this should be a good time to stop for now. And I will come back maybe a bit later to continue this. Thank you all for watching. Hopefully this was useful for somebody. Have a good day.